The final video in our trig integrals section involves using the product identities. So let's review what the product identities are first. Before I tell you what the formulas are, we're going to actually have three different formulas. And I really want to draw attention to the differences between the left-hand side of each formula. So for the first one, you have a sine and a cosine. The angle is always AB, A and B. For the second one, you got two sines, and for the third one, you have two cosines. Okay, so I think the easy way to remember these is to look at the different cases. Now let's look at the right-hand sides of each of these equations. They're all going to have the same shape. So it's all going to be like 1/2 times some quantity. And the quantity looks like this. It's going to be sine of A minus B plus sine of A plus B, and then we close off that square bracket. So let's highlight this. This is our first product identity. And I want us to pay special attention to the shape of this. So let's take a look at the second product. The second product, instead of having a sine and a cosine mixed together as a product, we have two sines. So it's going to have the same basic shape, which is 1/2 square bracket. And we're still going to have the angle A minus B and A plus B. And in fact, all three of these product identities have the same shape. So it's going to be 1/2 times quantity, and our angles are still going to be A minus B and A plus B. So those parts remain the same. That shape remains the same for all three of these product identities. Now, going back to this second one in particular, when these two trig functions being multiplied together are the same, we're actually going to have cosines instead of sines. So this is going to be a cosine here and a cosine here. We're going to have same thing. When you look at the third one, these are the same trig function multiplied together. So you're going to get a cosine and a cosine here. So you might be asking yourself, well, these guys basically have the same shapes. What's the difference between the product of two sines and the product of two cosines? The difference is the addition or subtraction in the middle here. Okay, when you have the product of two sines together, there's going to be a minus between them. And when you have two cosines together, there's going to be a plus between them. Okay, so let me highlight these two formulas we just described here. And remember, the only difference between the second one and the third one is going to be the signs. So maybe I'll highlight those two signs as well, just to draw your attention to that. All right, folks, let's look at an example. So we want to calculate the integral of sine of 4x times cosine of 5x. So I hope we can see that this is going to be the first product identity that we saw. So let's apply the formula. In this particular case, just to be explicit, our a is equal to 4x and our b is going to be equal to 5x. So when I apply my my formula, it's going to be 1/2 square bracket sine of 4x minus 5x plus sine of 4x plus 5x. I'm going to close that square bracket, dx. Okay. Let's do a couple things on the next step. Let's first, because I have a constant here times my entire integrand, I can factor that constant out of the integral, so we'll put the 1/2 on the outside. And then let's simplify each of those things inside the square brackets. This will be sine of negative x, and this will be sine of 9x dx. Okay. Now, for this first integral over here, this guy right here, I can use the fact that sine is an odd function. So the fact that sine is an odd function means that sine of negative x is equal to negative sine of x. So let me write that down. So this is going to be 1/2 integral of negative sine of x plus sine of 9x dx. And what I use to go from there to there is the fact that sine is odd. Sine is odd. This means that sine of negative x is equal to negative sine x. Okay. What about for the second integral? Well, for the second integral, I'm going to need to use u substitution. We're going to let u equal to 9x. This means du dx is equal to 9, which means dx is equal to 1 over 9 du. So let's rewrite our integrals. Let's split into two integrals. We're going to have negative 1/2 integral of sine of x. And then for the second one, we're going to have a plus 1/2 integral sine of u times 1 over 9 du. That's using our substitution. And we're running out of space here, so let me wrap this up in one step here. So the antiderivative of sine is negative cosine, but we have a negative out in front there already. So in the end, we're going to have 1/2 cosine of x. That's the first integral. For the second integral, we're going to have a 1/2 times 1/9. So that's going to give me a 1/18. So it'll be plus 1 over 18. The antiderivative of sine is negative cosine. So actually, I'm going to change that plus to a minus here. And then I'm going to have my cosine. And then lastly, I don't like to have a u in my answer, so I need to sub the u back. So that's going to be 9x plus c, of course. Okay, so let's highlight this. And this is solving trig identities using the product identities. All right, everybody, take care.